Still on binomial theorem, you have the following question. A salesman makes a sales on the average 40% of the customer he contacts. If 4 customers are contacted today, what is the probability that he makes sales to exactly 2? Now, if 4 customers are contacted today, it means that our n, which is the sample space, is how many? N is equals to 4. Now, if n is equal to 4, now they told you that 40%, right? It means our P is equal to what? 40%, because the probability that every day when he makes a call, 40% on the average, usually he says to them. So the probability that he must surely sell is 40%, which is 40 divided by what? 100. 40 divided by 100 is 0.40. The next one is our Q. Q is always 1 minus P, which should be what? 1 minus 0.40, and that is equal to 0.60. Now, they say, what is the probability that he makes sales to exactly 2? So the event that is likely to happen now is what? 2, our X. So bringing out our formula again. The formula is our P of X, probability of X is what? N combination X, P raised to the power of X, Q raised to the power of what? N minus X. And this will be equal to P of S will be, what is all this case now? Our S automatically changes to the value, which is this case is 2. So this becomes, what is our N? 4. So this becomes 4 combination 2. Our P is what? 0.4 raised to the power of, what is our X? Is 2 times what? Our Q is what? 0.60 raised to the power of, our N is 4 minus then 2. Now we know that this becomes 4 combination 2 then times what? 0. This is times rather 0.4 square times what? 0.60. 4 minus 2 is what? Is 2. So at the end of the day, what are you going to have? When you press this in your calculator, it's going to give us final answer will be equal to 0.3456. Now we know that whenever you have anything, for instance, this 4 combination 2 is the same thing as what? 4 factorial all over what? 4 minus 2 what? Factorial 2 factorial. Now what do we normally take? This becomes 4 factorial all over 4 minus 2 factorial is 2 factorial or 2 factorial, which should be what? 4 times 3 times, you break it down until you have something under that you can easily divide with, and that will be 4 times 3 times 2. There is 2 factorial under, so this becomes 2 factorial times what? 2 factorial. 2 factorial cancels 2 factorial, so we have 4 times what? 3 divided by 2 times 1, because 2 factorial means 2 times until you get to 1, and this gives us 12 over what? 2, and 12 over 2 will give us 6. So that is how to simplify this combination. Of course, we know all these other ones, they are what? Normal fractions, and then you substitute into this equation, you get this answer. But you can easily press this directly in your what? Calculator to get your answer without following this process. Now let's take the next question. The next question says the average number of defective pieces in the manufacturing of an article is 1 in 10. Find the probability of getting 3 defective articles in a packet of 10 articles. Now, they gave you a packet of 10 articles. So our sample space, which is our N, is 10 articles. Probability of getting exactly what? 3 articles. So it means our X is what? 3. Then our P is 1 in 10. That means 1 over 10. The probability 1 over 10, which is 0.1. Now, what do we do in this case? Is substitute into this what? Equation, or the equation. What is the equation? The equation for binomial distribution is N combination X. Okay, let's say P of S is equals to N combination S. P raised to the power of S, Q raised to the power of what? N minus X. Now, substituting into this equation, what are we going to have? We are going to have 10 what? Combination 3 Then our P is 0.1. But we've not looked for our Q. Our Q is what? 1 minus P. So Q will be equals to 1 minus 0.1, and this is equals to 0.9. So this becomes 0.1 raised to the power of our X is what? 3. Then we have times our Q is 0.9 raised to the power of what? N is 10 minus 3. And this gives us 10 combination 3 bracket what? Or times bracket 0.1 raised to the power of 3 times 0.9 raised to the power of 10 minus 3 is what? 7. And at the end of the day, what are you going to have? You're going to have 10 combination 3 times 0.1 everything raised to the power of 3 times what? 0.9 raised to the power of 7. Now, how do we provide solution to this question? What will be our main value or our value after calculating this with your calculator? So the answer we got for this is equal to 0. Then we have 0.57, and that's the answer to this question. So the probability of getting 3 defective ball is what? 0.057. 0.057. That's the answer to this question. Let's take the next question. The probability that a student will graduate is 0.4. Determine the probability that out of 5 students, none will graduate. Now, out of 5 students, so the sample space given to us is what? N is equals to 5. Now, the probability given to us is what? 0.4, which is P. Now, our Q is what? 1 minus P, which is equals to 1 minus 0. Equals to 1 minus 0.4. And that will give us what? 1 minus 0.4, I think, is 0.6. So that's the probability that a student will graduate. Now, the next thing is to calculate for our X. Said find the probability that none will graduate. Now, if none will graduate, it means our S is equals to what? 0. Now, bringing out our formula, probability of X is equal to what? Is equal to N combination S, P raised to the power of what? S, Q raised to the power of N minus S. So in this case, what do you do? Substitute into this equation. Probability that none will graduate, which is 0, is what? 5 combination 0. Then we have 0.4, which is our P, raised to the power of what? 0, times our Q is what? 0.6 raised to the power of our N is 5 minus 0. And this will give us 5 combination 0. Of course, we know that anything raised to the power of 0 is 1. So this sum up to 1 times. Then we have 0.6 raised to the power of 5. Is that so? 0.6 raised to the power of 5. Now, what do we do at this point? We punch our calculator and I will get our answer direct. The answer to this question is 0.07776. So that's the probability that none will die. The next one is the probability that 1 will die. It's not 1 will die, rather 1 will graduate. Sorry about that. Probability that at least 1 will graduate, rather. Now, the probability that 1 will graduate, it means that our X is equal to 1. Are we getting it? It means that our X is equal to 1. Sorry. Means that our X is equal to 1. Now, solving becomes P of 1 will be equal to, what would this one give to us? 5 combination 1 times what? We have 0.4 raised to the power of 1 times 0.6 raised to the power of 5 minus 1. And this will be 5 combination 1 times 0.4, anything raised to the power of 1 is still that thing, times what? 0.6 raised to the power of what? 4. This will become 5 combination 5 combination 1 is what? Sorry about this. Let me just sum it up instead of giving long processes. Now when you punch this in your calculator, it's going to give us 0.2592. Now the next one is probability that what? So that's the probability that at least one will graduate. Probability that at least one will graduate. The next one is, or probability that one exactly will graduate. The next one is probability that at least one will graduate. Now at least one means probability that one will graduate plus the probability that two will graduate plus the probability that 3 will graduate then plus the probability that 3 will graduate plus the probability that 4 will graduate plus the probability that 5 will graduate. Is that so? The probability that 5 will graduate. So we've already gotten the probability that 1 will graduate. Let's calculate the probability that 2 will graduate. 2 will be what? 5 combination 2 times what? 0.4 raised to the power of 2 times what? 0.6 raised to the power of what? 5 minus 2. Now 5 minus 2 is what? Is 3. So I can change this now to what? 3. And when you compute this, it's going to give us probability that 2 will graduate is 0.3456. Let's continue. Now the probability that 3 will graduate will be what? 5 combination 3 times 0.4 raised to the power of 3 times 0.6 raised to the power of 5 minus 3. Now 5 minus 3 is what? 5 minus 3 is 2. So this will give us raised to the power of 2 here. And when you compute this, it's going to give us 0.2304. Now the next one is the probability that 4 will graduate. Is what? 5 combination 4 times what? 0.4 raised to the power of 4 times 0.6 raised to the power of what? 5 minus 4. Now 5 minus 4 is what? Is 1. So we can erase this and put 1 here. Okay? And this will be equal to. So when you compute this with your calculator, it's going to give us 0.0768. That is the probability that 4 will graduate. Now the next one is probability that 5 students will graduate. It's equals to 5 combination 5 times what? 0.4 raised to the power of what? 5 times 0.6 raised to the power of 5 minus 5. 5 minus 5 is what? 0. So 5 combination 5 times what? 0.4 raised to the power of 5 times 0.6 raised to the power of what? 0. Anything raised to the power of 0 is what? 1. So this sum up to be 1. Now when you press your calculator for this, what is it going to give to us? It's going to give us 0.01024. Now after this, what do? We sum all of them together. So summing all, we are going to have the first one is what? Probability that 1 will graduate. If you come here, probability that at least 1 will graduate, probability that 1 will graduate is 0.2592. So we come here, write 0.2592 plus probability that 2 will graduate. Probability that 2 will graduate is 0.3456. 0.3456 plus the probability that 3 will graduate 0.2304 plus probability that 4 will graduate 0.0768 plus 0.01024, and this sum up to give us 0.9224, and this is the answer to this. Sorry, my hands are very straight, okay? And this is the answer to this question, okay? 0.09. Now we have another question, which is the last question here, that says all will graduate. Probability that all will graduate is what? It means our x is equals to what? 5. Are we getting it? So the probability that all will graduate is equal to what you have here, because if x is equal to 5, that was what we calculated, and the value is what? Is 0.01024. So the probability that all will graduate is this. So our IV, question IV, has this answer, 0.0125. You write this again, then put IV on the probability that all will graduate. So that is basically all for the binomial distributions. Now in our next class, we are going to look at something entirely different. Thank you for your time.